The next thing to look at, regions in the plane, which is still inequations, but just now using two pronumerals instead of one. If we were plotting an inequation on a number line, the first thing we would do would be plotting the critical points, so the boundaries. Well, when it's in the plane, it's going to be the curve that we draw first. And when we draw it, if the line is not included, so less than or greater than, we use a dotted line, because remember, dotted lines, just like asymptotes, indicate this isn't actually part of the solution, it's just the boundary. But if it is included, so greater than or equal to, less than or equal to, then we use a solid line to indicate, yes, this boundary is included. Now, the points of intersection of the line. If the point is included, then both of the boundary lines need to be solid. If one of them is not, so in other words, if one of them is less than or greater than, then just like we would on a number line, we circle the point to indicate it's not included. And then we test a region. Again, same as we would do with a number line. Start with a very simple one. Y is less than x plus 3. We draw in y equals x plus 3, but we dot it to indicate the boundary is not included. And then we test something which is not on that boundary, so we can see which side are we on. Well, 0, of course, is the easiest number to substitute in. When we're talking about points, it would be the point 0. 0 is the easiest to substitute in. And if I did that, not that you'd probably write this down, you'd be doing this in your head probably. 0 is less than 3. Oh yes, it is. 0 is less than 3. Therefore, we're on the right hand side of this line. 0, 0 is included in that region. We have a circle, x squared plus y squared, but this time greater than or equal to. So the boundary is included. So there's our circle, radius 3. Again, we've broken it up into two sections. This time it's inside the circle or outside the circle. So let's test 0, 0. Is 0 greater than or equal to none? Well, no, it's not. Therefore, we must be outside the circle. Semicircle becomes interesting. Now, y is less than the square root of 4 minus x squared. Okay, so we have our semicircle. Are we inside the semicircle or outside the semicircle? Well, let's test 0, 0. And 0 is less than 2. So we're inside. However, this one is unbounded. So like on the number line where we kept going to infinity, this would keep going to infinity. So we actually are also down below. But notice this. Once we go below this x-axis for this inequality, the boundary line would be included. Because if you were to test a point on that line, it would satisfy the inequality because all the y values here are negative. So of course we're going to get something that's less than the positive square root of the number. So we actually have this as a solid line, but we have a dotted line meeting a solid line. Therefore, we should circle the points of intersection to indicate, hey, the point of intersection is not included. Then we get regions which are bounded by two different functions. So we've got y is greater than or equal to x squared, but also y is less than or equal to the line 3x plus 4. Well, let's just do y equals x squared first of all. Our parabola. Are we inside the parabola or outside the parabola? I can't use 0, 0 in this case because it's on the boundary. So I need to pick a point where I know its location. So I picked 0, 1 because I know that's going to be inside the parabola. And yes, 0 is less than or equal to 1. I know I'm inside. I'm not going to shade it at this stage. I might mark some crosses or something like that so I know, all right, I'm inside. Now let's look at the other one. Y is equal to 3x plus 4. Okay. Well, what are those points of intersection? They're always interesting to find I'll find those, x equals -1 or x equals 4. So all right, I've got my 2 points of intersection. But let's test a point. I can use 0, 0 for this one because it's not on the line. So let's test that one. And yes, that's true. I'm looking for the section, I've used colour, where I have both blue crosses and red crosses. I must be in that section there. In this case, I should also dot the line and the parabola outside that region because they are not part of the solution. So they should be dotted. So 3 epsilon regions in the plane.